Thank you so much. We have Dr. Sanjay Moghe, CEO RFIC Solutions USA. We request Mr. Rahul Amrutkar to kindly felicitate sir. I request Dr. Moghe sir to brief us about the joint research and patents by the industry and academia.
Research and patents by industry and academia together. We are in the chip industry. In the cell phone, we make chips for cell phones and mobiles, Wi-Fi, Bluetooth. So let's go to the next chart. So basically, we have to understand the significance of joint research and patents. In our industry, which is VLSI design, integrated circuit design, maintaining leadership is very important. So advanced R&D and keeping ahead of the competition, joint research is very important. It also prevents competitors from copying our products if you keep on developing new products. And the cost of R&D is very high. So one way to lower the cost is really by having the industry and universities collaborate. So we have done that with a number of universities. We have signed MOUs. But in the process, we also find lots of challenges. Our company, we are based in USA and also a company in Pune, Hadapsar. We are involved in chip design for a lot of our customers as well as training students in chip design and VLSI design. So we offer all types of opportunities for partnership between industry and institutions, where we have a lot of student projects and joint projects with students, advanced research where we propose research projects. We also have industrial visits. So lots of different ways to collaborate are happening. We are involved in both colleges in Nagpur as well as in Pune. But there are many challenges. So I'll describe to you some of the challenges in working together. Let's go to the next chart. So this just summarizes what we do. We started in one office in Nagpur in 2005, and basically we are doing all types of chip designs. Most of these chips are for cell phone and wireless applications, and we are currently in design service. We basically offer these chips as a design service, and we work with all these technologies, silicon as well as gallium arsenide. Next chart. My background is, I have been in the chip industry in the USA for almost 35 years after my PhD from US, and then I worked for a number of big and small companies. Let's go to the next chart. And we have published lots of papers and published and got patents also. In the next chart, in the area of chip design, what we are offering is basically very advanced chip designs and printed circuit board designs, as well as ultimately complete cell phone. Next chart. So these are some of the examples of things we have done. One of the chips below, and I'm just showing you because it kind of shows what are the difficulties. The chip on the left below is really a IoT chip. We designed a Internet of Things chip, which is a 900 megahertz transceiver, and that chip took us roughly 2 years. 2 years plus roughly a team of 12 people. And these people are people who are extremely trained in this, so this work is extremely difficult. The one in the middle is a Wi-Fi board. We designed a complete Wi-Fi board. The one on the left, on the right side, is a 40 gigahertz chip. So some of these things are very difficult, and the challenges in collaborating with universities is, very few universities can do this kind of work. So first is you have to train them, and training them takes 1, 2, 3 years. So how do you overcome those challenges? Let me show you some more things. Let's go to the next chart. This is some of the past work we have done. Let's go next. So this is one example of the chip we did, and here we only did the half of the work. Our Japanese customer did the left side on the top, which is the digital baseband. They did that whole design in Japan, and we did the radio frequency design, and just the half of the radio frequency design took us roughly 2 years, and that too a lot of training. So what challenge we have in collaborating with universities and colleges how do you do this kind of advanced work in India when really most of the colleges just teach theory, and theory is not enough. You have to actually build the chip, fabricate it, test it, and all of that is not taught in many colleges, you know. So we work with colleges and teach them, and this is, IoT is very important application, is coming everywhere, and this is one of the chips we did a few years back. Let's go next. This is another chip we did for, this is a cell phone chip, and most of these customers, the application of these chips are not in India. Most of these customers are outside India. And the reason for that is, chips are not required in India yet. When you start making phones, then you need the chips. Currently, most of the phones are being bought from, China or other outside India. So really, we feel we are a little bit too early for this market in India. But we did this for a customer in US, and it's basically it's a very high data rate bus, which is a gigabit data rate bus. So we did that chip for them, and again it was another challenging chip, which took almost 10 people over a period of 1.5 years. Next, this is a synthesized source, which is a phase lock loop system, and this again was another challenging chip. Go next. So these are some of the. So we use the tools. Many of you students here are really lucky to have a college like this, which has. I was just upstairs. You have a very good lab in VLSI design, and I saw you have very good mentor tools. So the tools required for this, we have used both mentor and cadence. But to train on mentor and cadence takes at least 6 months to a year. So that's another challenge. How do you train people? And this is only at the master's level. Most of the bachelor's level students don't learn this. But this kind of using these tools and playing with these tools is very important. So that is another challenge where very few colleges have these kind of tools. And these tools cost, a lot of money, $100,000 or even higher. And colleges get some discount. But in Pune, the tools you have in your college here is very nice, because only a few colleges in Pune have these tools, because everything in the chip industry is very expensive. So that's another challenge. Let's go next. So these are some more examples of chips we have done in gallium arsenide. Next, this is a 1 watt amplifier inside a cell phone. So this is another chip we did for a customer. Again, this was a US customer, and it worked very well. Next. This is another example of a chip. This is a cable TV chip. So inside cable TV, you have a set-top box, and you also have cable TV signal goes from one building to next building. So this particular chip is used in amplifying the system. And this is another example of issues we face when we do this kind of work. So what happened was, we designed this chip and we gave it to a customer. They liked the design. They said, we not only want the design, we also want the actual chips. So they said, if you can make million chips, we can work with you and we can give you an order. So what we did was, basically the challenge was, we did the difficult part of designing the chip, but the resistors and capacitors used to make the PCB was a big problem to get, because the chip resistors and capacitors were very hard to get in India quickly, So we had to kind of not do that project, because getting delivery of chip resistors and capacitors took a lot of time. But all these problems are getting fixed, because more and more companies are starting in India. So let's go to the next. Why don't you skip this? Go next. I will just show some charts at the end. These are the markets we are addressing. So most of these chips are used in all these markets. Next. Go next. 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 Yeah, so this just stop there. So we are helping here with some of the companies that are getting into manufacturing. So our Prime Minister Modi ji has a very good goal of make in India. So there is a lot of incentives to make in India. So we have lots of chips. We would like to manufacture millions of chips in India. and we already have the designs. I spent roughly few crores to make a company that can design chips very well. Now we are looking for investment to manufacture chips in large quantities. So we had some companies who were saying, can you help us in manufacturing of phones? And we looked at that and we said, yes, we can help you with design service. But ultimately we would like to make phones as well as chips in India, and that requires some investment. So we are currently involved with a number of companies in helping them, and it's good to see that finally some companies are making phones in India. If we get investment of this type, we could get into both phone as well as chip manufacturing. Next. We also offer products, a complete embedded system in smart cards for colleges. So it's a software, hardware, everything combined. These are smart cards which are used for, in college for library, for payment, for issuing books in the library, for basically a card which will have a wireless chip inside, which can basically do 50 different things. So we have these kind of products also. But I will stop here and really take any questions you have. Thank you. Manufacturing, but really very few people need chips in India. Chips will be required in India only when you make phones or so probably in another 5-10 years there will be bigger market. But market for chips is really further down. The markets for chips is there in China and rest of the world. They need a lot of chips. So we have a lot of customers from China who want the chips. But we have to set up an operation there, But in India, probably the design service, the kind of things we are doing, you can do, there is a market for that, but that is also mostly for foreign companies, Because very few Indian companies, invest in technology at this point, I don't know, does that answer your question? Thanks.
Sir, hello sir. I have a question about the patents. Sir, actually I have 2 patents and I have a third idea about the public sectors like railways and buses. I want to more develop them. So what kind of some permissions or other legal things I should complete for them?
So I had few charts on patents towards the end which I couldn't go because we had limited time. But many of the patents I have are in US. In US patents, there is a way to go through procedure for filing those patents. In India, you can file with the Indian government, but really your protection is only there if you really file worldwide patents. And patents in US cost a lot more money. But if you want to file, at least file in India, the costs here are less. Cost in US is at least few $1,000s, So
I have filed 2 patents, so I need the third patent, and it is in railway sector. So what kind of information or permissions should I take from the railway ministries?
No, if it's your own invention, if your own ideas, you can file those patents, third patent also, because you already have 2 patents.
So, but we don't have the authority to change the public sector's some machineries or
No, patent is just about an invention, so you can propose whatever you want to propose. The railway may not implement it, but you can file the patent without the railway's permission. If railway wants to use it, then they will have to come to you. So you should just go ahead and file the patent anyway. You don't need railway's permission. Railway's permission is required if you want to use their equipment and you want to go inside the equipment and modify it and design, then you need their permission, because they will not give you details unless they give you permission to look at the details of their equipment. So if you can file the patent without looking at the details of their equipment, you are free to do that.
Thank you, sir. Thank you so much.
You're welcome.